Okay, so it's almost British Science Week, which means probably nothing to you, but it means loads of schools have suddenly started contacting me saying, oh no, what are we going to do for British Science Week? Who did we have in 2 or 3 years ago? Let's contact them. And so let's see, it's a week away, or a week and a half away. I got contacted by 8 schools today. I'm not saying they're badly organised, and there's lots of other pressures in life, but I've had to say no to at least 3 of them because we've got other bookings. The other ones, there's a possibility they've got a bit of flexibility, so we'll just have to see. Anyway, loads of ways of contacting us. The usual same 7 faces. Here's 7 faces. If you see them in the street, stop them. They are your trusted and loyal team looking after you. And the membership count was 148, but at 5 o'clock, someone became very interested, and we've just gone up to, it's actually 152 now. So it went up over 4. A family joined at 5 o'clock this afternoon, which is quite nice. And they've also put a booking in for a telescope. So hopefully they're legit, or they're after a 500 quid telescope. It's okay. I'll get to see them. Everyone thinks it's such a nice service. Simon comes and delivers the telescopes. Isn't it great? No, you're being checked out to make sure that it's an appropriate place, and I know where the telescope actually is going to be housed. And if there are any problems, we can have a chat about it. Okay, right, so that's us. What have we been actually up to in February? Why am I looking a little bit tired? Why are the crow's feet particularly, sorry, the bags under my eyes particularly large? Well, we started off, it was National Astronomy Week. Lots of people helped out, great for that. This is actually not us. This is Wells and Mendip, astronomers. Wells and Mendip astronomers, I'm also a member of them. I'm a member of quite a few different societies. And they put a shout out, can anyone come and help along? And I took 2 telescopes along to Wells and Mendip to help support them on their night. As it turned out, they had at least another 5 or 6, as well as the 2 that I brought along. But what they didn't have, because they haven't done much outreach, is the banter. Lots of people were walking past and looking and then walking away with their shopping. We've been doing quite a lot of outreach, and we sort of know to go up and sort of say in a very polite voice, would you like to see the stars? And that scares them off again. So you change the banter to, actually, would you like to look at Saturn? And then the mention of Saturn and their away. So Mike, you've got the easiest job talking about Saturn because everyone already loves the planet.
Right.
But we got to do that, and gosh, maybe about 100 odd people looking through scopes, which is great. And it's great for Wells and Mendip as well, because they don't do too much outreach. And they've kind of said, this was really good. And they're already booking more. Okay, so it's really good. It's actually started because I suggested they ran something, and then they organised it, and then I just came along. So they did all the hard work, and I just had a little bit of banter. But it's lovely to see other astro societies that are perhaps a little bit closeted for since COVID and things, not really stepped out, but now they are, and it was actually a really successful evening. We also attended, what was it called? The Rebalance Festival. Which was, the National Trust was hosting part of it at the Bath Assembly Rooms, and we got invited along with the Helios exhibition, so the Luke Jerram's Helios installation, and lots of people were lying around. This is actually, I think this isn't my photo, because I think that's my leg. So someone's taking a photo of me trying to take an arty photo of the sun. Oh, come on in. And we were there just talking about actually the installation. We were in a separate room, but as people came through, hands up if you didn't go. Did anyone not go? Oh, that's a shame. It's ended now, but that was a sort of a wonderful thing to actually just have a look. We've had Luke Jerram's The Moon and the Earth. So the only one we haven't had so far is Mars. So I've just got to convince the clergy at Bath Abbey that the bringer of war is an appropriate thing to hang in the middle of an abbey. You never know, lots of other abbeys have done it and lots of other cathedrals have done it. But they gave us a big room, massive room, and we were just filling it with 3 solar telescopes. But we had Roger's poster up, well, not poster, his image on metallic sheet there, it was great because they came from seeing Helios installation, a 7-meter wide dome, and not really understanding what they were seeing. And then we could stand by here and actually they'll be coming out soon. We could stand by here and actually explain to them what they were seeing. Okay, so a number of people talked about the deep, dark valleys on the sun. And so we got to explain, actually, that those aren't valleys. That's looking down on the top of a prominence, and we call them filaments in that stage. So it's actually above the sun rather than a valley on the sun, and things like that, just talking about it. And we even got outside. You wouldn't have thought in February. And for those people, the astrophotographers who've raved about photo pills as an app, I will also start raving about it, because we were given this little courtyard at the back of Bath Assembly Rooms. And if you know where the sun goes in the winter months, it's really low. And I thought, oh, the sun's hardly going to be above those houses right by the assembly rooms. And it was close, but Photo Pills said it would just scrape over the top for a few hours. So we booked it for those hours, and that's exactly what happened. So well done, Photo Pills. And lots of people got to see the surfaces of the sun for real. So they saw the NASA image, they saw Roger's image, and then they got to see the real thing. Although most actually suggested that Roger's was the best of all of them. So well done there, Rog. So that was a lot of fun. Gosh, we had, again, a few hundred people on there, and we're giving out lots of freebies. Some things we put out, we hadn't intended to be given out as freebies, but people took them anyway. So that's a lesson learned for us, that if you want to keep it, tie it down. What else we do? We were still going to schools. And so I think this is Manor Primary in North Bristol. So we had the telescopes out in the back there, and we ran an evening for them of doing God, what were we doing? I'm trying to remember. We were doing rocket launching, we were doing planispheres, and we were doing stargazing. So it wasn't great conditions, but it was one of those ones where you could get the kids to say, there's a gap in the clouds over there, move the telescopes. And so they really got into it, and lots of discussion about satellites. We saw lots of satellites, and we also saw lots of planets as well. So that was good fun. And we did lots of stuff with young people's organizations, mainly Cubs here, and they cleared the room, so they gave me 5 meters, and I said, oh, I think we might have a bit of a problem here. And we just managed to fit the dome in here, but this is in Salford as well. So this is Peas Down, this up and top left, and then bottom right, that's Salford. And this is all doing the Cubs, the new activity badges that the UK Space Agency has is running with the scouting organisations now. So great fun, and everywhere we're carting around our Rosemary Coogan. So everyone's getting to know who Rosemary Coogan is, our UK astronaut who's currently in Houston doing EVA training. So she's in the big suits, in the big bottom of the deep pool, working out how to actually safely move around the International Space Station. So she's got a few more months of doing that, and then she'll be on specific mission training. So that'll be good. Subject to Keir and team finding money to fund her trip to the International Space Station. Oh. And after a long, long gap, I think the last time we were at Monkton Observatory was back in June or July 2024. Our main contact there left the school, and we had a sort of a gentleman's agreement on how we would operate. So that had to be formalized with the people taking over. And formalized is a very short word to explain what's happened over the last 6 or 7 months. But we got to the point where everyone's happy with the draft text, and so we were allowed to come and use the telescope again. And so that was only just this weekend gone. But other than a few little tweaks and repairs and things that have been over-tightened or used incorrectly, nothing that's broken, it needs a bit of tweaking. So we'll just need to arrange for the school to go back and sort of tweak it. But we were observing Mars through the Victorian 1860s telescope. So that was kind of fun. So I enjoyed all of that. Hopefully everyone else enjoyed it, didn't get too cold. Yeah. We learned that all the telescopes we had out just love condensation. So Have to definitely remember next time to take the dew heaters and the dew shields for all of those telescopes. It's there's just too much moisture around not to take those bits and pieces. And also, thanks for all the support, because this is also National Astronomy. This is the end of National Astronomy, and our guest star at the edge of the photo, she always thinks she gets out of my photos, but she gets into them. So we've got Prim there, but we ran, gosh, 2 days of public planetarium sessions, all about chasing the moon. And so we wrote 2 shows, one about sort of generally how to track night by night how the moon changes from the 1st of February to the 9th of February, and then a special show just on the moon, its orbits, how it changes, eclipses, that kind of thing. And we were showing those 2, and we were giving out loads of packs as well. But this time we'd learned, we only put out stuff that we actually intended to be given out for free, and it worked really well. We ran a competition, and someone won a telescope. So that was good. So we were donated a telescope. It's not the kind of telescope that we would use for normal outreach. So we put it up, and the committee selected the best entry, and it got delivered to Radstock, I think it was, there. So it's been quite a busy old month. What have we got coming up? We've got talks coming up. We've got Hugh Allen, who's going to be talking, actually, I've got a slide on that one. Hopefully, Dr. Megan Christiaan, she is the reserve, UK reserve astronaut. So if Rosemary has a bit of whatever problems, she decides to give up and go back to astronomy full time, Dr. Megan is the reserve, but she's currently training in ESA. So the reserve astronauts have all been called up to do their training. So fingers crossed, she'll still be available to come to talk to us on the 30th. So I'm slightly nervous about that one, but I will start contacting, and hopefully they'll get back to me quite soon. Dr. Gemma talking about space weather, and then we've got members night. So I will soon be going around saying, who wants to talk to us in June? So you get anything from 5 minutes to 15-minute slots. 15 minutes is quite rare. It's more than about 5 to 10 minutes. Talk about what you've been up to over the last year or so. What projects have you tried? What have you built? What have you had built for you, Ben Luger, if you're out there? In terms of, say, some of Mike's inventions, you may, if you've been on some of the WhatsApp groups, you've seen that people have been building stuff for other members, and then those other members have been sort of enjoying the fruits of all that industrious labor. So we'll hopefully get some talks going there. And we've already started booking next year's season. So our season restarts in September. And I've convinced, oh, I've spelled his name wrong, Dr. Robert Massey. He's the Deputy Executive Director of the Royal Astronomical Society to come and talk to us. I've been badgering him for years. And so it's great that he's got, he used to live in Bristol, so I badgered him at the wrong time. I should have badgered him when he lived in Bristol, because it would be really easy to, but now he lives in Kent. But he has promised to come along, and a colleague of Andy's, a colleague of Roger's, you might be aware that Roger does something called Space Oddities. He does a sort of radio podcast show on Tuesday nights, and the person that sort of is at the helm is a chap called Andy Briggs, who's a science communicator, a writer, and he's probably going to talk to us about black holes. It's a sort of specialist subject. We might try out a new venue. So we'll talk about that, Mia, about whether this is the right opportunity to do that. And also from Bath University, always go back to the team up there. Dr. Vicky Scowcroft is going to talk to us and sort of round off the year, unless we have a winter warmer. So we've got quite a lot going on. I just let, oh, he's doing this in. Oops. The roller. Right. So next month, we've got Hugh coming to talk to us. He's the chap on the left, and he's going to be talking about the life and work of Sir William Huggins, a very famous spectroscopist in the 19th century. Lucky I haven't had any drinks. It'd be really hard to say if I had. Hugh is the chair of Wells and Mendip Astronomers, and he's been bolting spectroscopes on the back of telescopes for years. And so he's been looking at the way that spectra on particular astronomical objects change. It's what William actually pioneered. And he started it back in the 1850s. So he's the first. He then went on to actually start using spectroscopy on things like nebula to work out whether galaxies and nebula were the same kind of things. And he discovered that they were different. Galaxies appeared to be more like star sources, whereas nebula were actually appeared to be emission. So star sources are effectively, you see a continuous spectrum with lines in, black lines through, whereas nebula appeared to be sort of individual single lines. And that gave us the clues to what these things were made of. Up until he did that work, it was guesswork. What were galaxies and what were nebulae? But he was aided and abetted in pretty much everything he did by his wife, his junior by 24 years. Wow. But that was kind of normal in the 19th century. You got to the age of 51 and you got yourself a young bride. Yeah, it's still a bit odd. Anyway, she was really into science and really into astronomy. And basically, she was almost as important in the relationship, important in terms of the discoveries and what was going on, as William was. Without Margaret, then William wouldn't have achieved what he achieved. Absolutely. And so in terms of credit, it's actually the story of both of them rather than just the individual William. So here we take as the story of the pair rather than just William. So sort of interesting of how all those discoveries. He effectively was the first. If you're into astrophotography, William started it. So he came up with a dry plate process for actually starting to image the night sky. He worked in collaboration with lots of different people, but he was there right at the start of it. So even one for the keen astrophotographers. Anyway, I have talked too much, haven't I? So let's get on to the main event, which is going to be Mike. He's going to talk to us about Saturn and sort of that beautiful thing. Now we've lost Saturn. Your talk is going to have to replace the fact we've lost Saturn, Mike, to the evening sunset. I tried to see it last night next to Mercury and it had already gone. I couldn't separate it from the glow. So bring it back into our hearts, especially because it's going through that wonderful moment at the, sort of where it's pitching up and we're going to see the rings edge on. I say we're going to see it. Okay, the rings will be edge on, but we're not going to see it. But that's great. So why Mike? Well, I met Mike at the Southwest Astro Fair last year. And every speaker should know that when you finish up, the most important thing is to get your bag filled with your computer and head towards the door. Mike committed the cardinal sin if he backed off to a corner, which meant all the people from Astro Societies came up and said, Mike, do you do talks? So that's how we've got Mike. He went the wrong way, but no, he's the director of the BA Saturn, Uranus and Neptune section. So he gets all of the beautiful ice giants and gas giants apart from Jupiter. And I think you've been doing it since 2007, Mike, is that right?
Right, that's right, yeah.
Yeah, so it's one of those jobs you just keep loving, or is it just no one else will take it on? I don't know. But yeah, so can you put your hands together? Thank you. We're going to turn it over to Mike now.
Oh, thank you. Good evening, everyone. Hope everybody can hear me okay, and the slide is on the screen. It's very kind to be invited to Bath Astronomers. It's been quite a few years since I was in Bath, but whenever I've gone to Bath, I've always ended up in the William Herschel Museum. A little bit more about Herschel a little later on. And I hope everybody's keeping well, and the weather down there is a little bit better than where I am up in Bedfordshire, because it's been pouring with rain most of the day, but there's been a few clear patches and I could see Venus about half an hour ago. Anyway, let's kick off. I suppose that many of us were brought up with books by the late Sir Patrick Moore. He used to do a lot of really good guide books to the night sky and many other good ones around. And often as not, these books describe some of the highlights you can see in the sky, particularly with small telescopes. We can think of the moon, we can think of things like the Orion Nebula and the Pleiades, double stars like Albireo and Mizar, and almost to a book, they'll also mention as a highlight the object we're talking about tonight, the planet Saturn. Why is Saturn deserving such an accolade? Well, that's a daft question on my part to ask an audience such as yourselves, because we all know why. It's surrounded by this rather splendid system of rings. Now, I, for one, am not saying it's the most spectacular thing in the sky. There are many other things that's spectacular. I mean, last year we had some great auroras, which are really good, but certainly it ranks in the top hierarchy of spectacular things to see in the sky. Now, if anybody had been talking about Saturn pre-March 1977, they might have talked about Saturn with its unique ring system. But since that time, we've found that the other giant planets in our solar system have got rings. There's a Centaur asteroid, Chariklo, that may have a ring system. Some of the satellites of Saturn have ring arcs associated with them. And who knows, maybe some of the exoplanets that have been discovered have got ring systems around them. But where Saturn's main ring system remains unique, it's the one system that could be, under most circumstances, be detected with quite modest optical aid. But in addition to the rings, Saturn is our second largest planet in the solar system. And the people who study the evolution of the systems think that it may have had a key role sculpting the solar system as we know today. In addition, it's got a large family of moons. I'm always losing track, but I think it's up to 146 now, and a large magnetosphere. So it has a lot of things going for it, which it would be impossible to compress all of that into one talk. So tonight, I'm just going to give a very brief overview. I'll obviously talk a little bit about the rings. Can't talk about Saturn unless you talk about the rings. A little bit about the planet and its upward atmosphere. But to kick off with, I'd like to do a little bit of historical context. Saturn was known to the ancient astronomers, but when telescopes came on the scene, the thing that flummoxed these astronomers was its apparently changing appearance. And the story really begins with this guy, Galileo Galilei. Born in 1562, became a professor of mathematics at various universities. He certainly didn't invent the telescope. And in fact, Thomas Harriot in this country may have looked at the moon with a telescope a couple of months prior to Galileo. But most of his observations were groundbreaking. And amongst the many things that he did find was a series of up to 4 stars that seemed to keep pace with Jupiter as it moved around the sky and seemed to move one side or the other. He named these the Medici stars to try and curry a bit of favour with the powerful Medici family at the time. Excuse me. We now know these are the 4 largest satellites of Jupiter: Io, Europa, Ganymede, the largest satellite in our solar system, and Callisto. And we see them in a rough line because we view their orbits almost edge on to the plane of the orbits. He then turned his attention to Saturn and perhaps unsurprisingly found that this too was a multiple object. It seemed to have 2 attendant objects on either side. But unlike the satellites of Jupiter, these 2 objects stubbornly refused to move. And to cause Galileo a bit more consternation, a couple of years after his discovery in 1610, they actually disappeared. Most of the astronomy books who do historical things say Galileo quoted that Saturn's eaten its children. I don't know if that's true or not, or apocryphal. But whether Galileo was worried about this, I don't know. But they eventually reappeared in his telescope. And what he didn't realize, of course, that he actually discovered the main ring system of Saturn. And this, what was a very crude telescope, it could only resolve the brighter, wider parts of these rings as they were projected onto the sky. Over the next 30, 40 years, various observers got telescopes and started looking at Saturn. And here we can see some drawings that were made. Some look like the Saturn and rings that we know and love. Others look a little bit weirder. And various theories were propounded of what they were seeing. Some people thought that Saturn was like a modern day rugby football with dark markings on it. And as we viewed it from different angles, gave the change in appearance. Others thought there were dark and light eclipsing bodies causing the changes. Even thought of gaseous emissions or even arcs fitted to the planet. But it was about 40 years later, after Galileo discovered what we know is the rings, the true nature of the rings were found out, and it was done by this guy, Christiaan Huygens. He was a Dutchman, and he was absolute polymath. This guy did everything. He was a mathematician, a physicist, an optician, an inventor. He invented the pendulum clock, and an engineer, and did all sorts of things, and interested in astronomy. And like many of his contemporaries, had single lens refractors, which gave a lot of false colour. And to overcome this, some of the telescopes were of ridiculous lengths. Probably the most extreme was by contemporary Johann Helvicki, who we know now as Hevelius from Gdansk, and he used this sort of telescope, nearly 47 meters long. This must have been ridiculously difficult to use. And Huygens even came up with an idea of a lens on a pole, a piece of string and an eyepiece at the bottom. Whether he used this or not, I don't know. But he used a telescope similar to the Hevelius one, a much more modest length, about 15 meters. And he studied Saturn, and he discovered Saturn's largest satellite, which we now know as Titan. And because of Titan's apparent path on the sky, it gave him a clue to what we was actually looking at in terms of the rings. And he eventually published several pamphlets, but a book called the System Saturnium, or the Saturn system. And inside there was a remarkable diagram. And this is my take on the Huygens diagram. I know it's a little bit busy, but I'll explain things as we go along. Huygens decided that what we were looking at was a ring surrounding Saturn, which didn't touch the planet and was inclined to the plane of its orbit. Now, Saturn's poles are inclined from the normal to orbit by nearly 27 degrees, whereas the Earth is just over 23.5. So Saturn, like the Earth, has seasons. In 2017, the North Pole was pointed towards the Sun, so that was the Northern Hemisphere solstice. And in 2032, the South Pole of the Saturn would be pointed towards the Sun, so that would be the South Pole solstice. And then as we've got the two equinoxes, and in fact, we're heading towards an equinox now in March, where it will be the autumn equinox for the Northern Hemisphere and the spring equinox for the Southern Hemisphere. But the rings actually orbit Saturn in the plane of the equator. So when we have a Northern Hemisphere solstice, the rings are at their maximum extent towards the Sun. And when we have an equinox, the rings will appear edge-on. And as Saturn moves around its orbit, we get different views of the rings. So it's not a physical change in the rings, it's just our view in geometry. But this doesn't tell the whole story, because this is what we would see from the Sun when we observe Saturn from the Earth. And the two orbits are inclined to each other by about 2.5 degrees. So for us on the Earth, we actually see the increase or decrease of the Saturn ring inclination plus an oscillation caused by the Earth as it moves above or below the plane of Saturn's orbit. Now, the rings are going to be edge-on to the Sun in a few weeks' time, but the edge-on phase to the Sun and the edge-on phase to the Earth don't coincide. So as we see at the top, the rings will be edge-on to the Earth in March, but they'll be edge-on to the Sun in May. And by some curious situation, if the rings are edge-on when Saturn's at solar conjunction, there's only one ring plane crossing with respect to the Earth. If it occurs at opposition, like in 2038, we actually get 3 ring plane crossings with respect to the Earth. And this does mean that at some point we can see the dark, unilluminated face of the rings pointing towards us. And you would think they were not visible, but with medium-sized telescopes, you can actually see a faint ghostly line, which is caused partly by sunlight diffusing through the rings and also light reflected off Saturn back onto the rings. And it's a rather beautiful sight. And certainly I would like to be around in 2038 when this next occurs. The next thing that occurred was by this guy, Giovanni Domenico Cassini. He's an Italian by birth, and he was a successful observer. So he was invited by King Louis XIV of France to design and build and become the first director of the Paris Observatory, the equivalent of Greenwich Observatory. In fact, this observatory is still in existence in Paris, and it lies on the Rue de Cassini, or Cassini Street. And he became a French national, and he changed his forenames from the Italian to the French. So we now know him as Jean-Dominique Cassini. He founded an astronomical dynasty. His son and his grandson were also astronomers. But what we remember him both about for Saturn was he actually discovered a gap in the rings, a line around that, which we now call the Cassini division. He was also the first person, I think, to actually see some banding structure on Saturn's disk. Cassini thought he was actually seeing a gap in the rings rather than a dark marking, but he couldn't prove it. And later on, later Sir William Herschel, who discovered the planet Uranus, but was also an avid observer of Saturn, made measurements when the north and south faces of the rings were presented towards the Earth, and found that the position of this Cassini's division was in exactly the same place. So he too thought it was a true division, but couldn't really prove it. And the actual proof had to wait quite some time until 1917, when Saturn's rings were predicted to pass or occult a star. It was about 7th magnitude, and it was observed by 2 British amateurs, a Captain Ainslie using a 9-inch reflector and a Mr. Knight using a 5-inch refractor. And they observed this event, and to their surprise, as the rings passed over this Saturn, they could see it faintly through the rings, proving that the rings were translucent. In fact, that star was actually passed through Cassini's division, and they were convinced it got up to almost the brightness it had prior to the occultation. Now, I appreciate this is a qualitative rather than a quantitative measure. It's got no electronic recording things, but it certainly proves that Cassini's division was actually a true division in the rings. And from time to time, Saturn does occult faint stars. And here's another observation of an occultation quite a few years ago now, of a variable star in Cancer, BY Cancri. It's observed by a British amateur up in the northeast, David Gray, and you can see the star appearing through Cassini's division. And occultations are a really great way of probing the ring structure. In fact, it was Voyager 1 or Voyager 2, I can't remember now, observed Delta Scorpio pass behind the rings, and it got a very sophisticated electronic camera on board, which was able to take rapid time images of this occultation, and they were able to probe the structure of the rings by using this equipment. The next discovery, at the time, we got the 2 rings that were visible, which the outer one known as ring A, and the brighter inner one was ring B, divided by the Cassini division. And the next discovery was made in the 1850s, when another ring was discovered, this ring inside ring B, which we now know as ring C, or the Crate ring. It was discovered by the father and son team of the Bonds, W.C. Bond and G.P. Bond, and they were using a 15-inch refractor, which would be considered a tasty instrument by anybody's standards. But a few weeks later, it was independently discovered by a British amateur, the legendary William Rutter Dawes, or Eagle-Eyed Dawes he was known as, using just a 6 1/3 inch refractor. And this is his drawing, and you can see ring C there as well. Now, we say this is an independent discovery because at that time, news took quite a while to travel, to get news letters across the Atlantic. And so many people will class Dawes as an independent discoverer. I suppose it depends on which side of the pond you live, but I suppose some people say Bond discovered them first, so they should get the credit. But I think Dawes needs some credit as well, and discovering this with a much smaller telescope. It was his great friend, William Lassell, who himself was an avid planetary observer, who called it the Crate Veil because it looked fuzzy. We now know it is the Crate ring. But surprisingly enough, it's surprising that its discovery had to wait until as long as the 1850s. William Herschel, as I mentioned before, was an avid observer of Saturn, and he often observed where the ring crosses the globe, and he thought this was just another band, and never once suspected it was actually part of a ring system. So by the sort of 19th century, this would be the knowledge what we have now. There's an outer ring, ring A, which is a little bit darker. The brightest ring is ring B, separated by the Cassini division, and the fainter ring C, which actually is easier to spot when the rings are at a narrow inclination to the Earth rather than a wide one. And a few other gaps have been discovered as well. One of the things that I think I find fascinating about this ring system is its sheer scale. If we go from the outer edge of ring A on one side to the outer edge of ring A on the other side, it spans an enormous distance, about 273,000 kilometers. Now, I don't know about anybody else in this room, but that numbers, that distance has sort of become meaningless. And to try and put the scale into some context, if we could suddenly pick Saturn and its rings up and drop them between the Earth and the Moon, the ring system would stretch roughly 70% the distance between the Earth and the Moon. So you can see they're quite big. But the other statistic that is quite fascinating is their actual thickness. They are ridiculously thin. Almost certainly they're not of uniform thickness, and we'll come to that a little bit later on. And it does vary around the rings, and estimates vary, but it's believed that on average, the ring's only a few tens of meters thick. So they've got an enormous size, but ridiculously thin. The ring system doesn't stop there. In the sort of 20th century, either through Earth-based observations or spacecraft, the ring system is found to be much more extensive. I'm sure many of you have seen this fantastic picture taken by the Cassini spacecraft, looking back towards Saturn. We see the light of the various rings by forward scattering light. We have the rings that we know and love, and inside ring C, there's a fainter ring called ring D. Just to the edge of the outer edge of ring A is the F ring, a very narrow ring, a braided ring, which was discovered by Pioneer 11, and also forms the subplot of a science fiction novel by Larry Niven and Jerry Pournelle called Footfall. When it was discovered, the strange shape of this ring caused scientists a lot of puzzlement. And the Living Pournelle novel, part of the plot was that this was actually caused by an alien spacecraft on its way to do nasty things to the Earth. Outside ring F, there's the faint G ring, and further out, there's the E ring, which is associated with satellite Enceladus. So taken together, if we go to the outer edge of ring E, which is rather fuzzy, this increases the size of the rings we know and love by about over 3 times. And in fact, on this picture, there's actually the Earth. So we're actually where the point of that arrow is. Well, that's where the Earth is. But the story doesn't end even there. In 2009, the Spitzer telescope actually discovered a faint, an incredibly faint infrared ring system that was associated with outer satellite Phoebe. And this extends to about 50 to 100 Saturn diameters away from the main ring system. It's inclined to that. So this ring system is very complex indeed. But what are the rings? Well, when Huygens proposed his ideas, what we're looking at, he explained the observations, but didn't actually say what the rings were made of. And for many years, many of the astronomers thought that they actually were solid sheets. But it was then that the great French mathematician Pierre-Simon Laplace did some mathematical analysis and proved that they wouldn't be stable if they were solid. And he came up with an idea of loads and loads and loads of tiny narrow ringlets all embedded inside each other. And this led to, certainly in the 19th century, for astronomers for looking for all these inner ringlets and looking for gaps. But it was then proved that this was dynamically unsound. And it was about the middle of the 19th century, the great Scottish physicist James Clerk Maxwell of Maxwell's equations for electrodynamics came up with the idea that these were actually made up of zillions of particles in orbit around Saturn. He gave a mathematical proof of this, why they would be stable, why this would happen. And it was proved a number of years later by an American astronomer called James Keeler, who put a spectroscope slit across the rings of Saturn and find that on one side they were moving towards us, they were blue shifted in light, the other side they were red shifted. And the amount of blue shift or red shift varied. It was a lot slower towards the edge of the rings than the inner edge, and this was in accordance with Kepler's laws of planetary motion. So this proved that the rings were made up of zillions of objects orbiting Saturn. And most theories now think that they're predominantly ice, and they range in size from tiny grains, tiny snowflakes, up to maybe the size of a car or a building. And this accounts, the predominantly ice, which accounts for the ring's brilliance as well. There was also a spate of discoveries of divisions inside the ring system. And some of these are caused by gravitational resonances. The inner edge of the Cassini division is caused by resonance with the satellite Mimas. The particles, Mimas takes twice as long as the particles take to go around Saturn. So they see a preferential gravitational tug from Mimas as they orbit. And this sweeps out the gap in the Cassini's division. Although Cassini's division is not a complete gap, there is material in there. In ring A, there is another gap called the Encke gap, which is caused by the satellite Pan. And then there's a further out a gap called the Keeler gap, which is swept out by a satellite that lies in it called Daphnis. And also on this picture, you can see the braided F ring, which is very narrow. And that's believed to be kept in its orbit by a narrow orbit by two satellites, Prometheus and Pandora. Although some scientists have argued it only needs one of these satellites to do this. The Encke gap actually was actually discovered by James Keeler, who did the spectroscopic measurements. And then I think it was Voyager discovered the gap, the outermost gap in ring A, which is now called the Keeler gap. For some reason or other, the International Astronomical Union, who decide the names of things, gave the name of the gap discovered by Keeler to Encke, even though he didn't actually discover it. And then they gave the smaller division to Keeler. So I always think Keeler's been seen off a little bit. But when we look at the rings, and what we're actually seeing is gravity in action. The rings are controlled by the satellites orbiting Saturn or within the rings and Saturn itself. And there's numerous gaps been found in other parts of the ring system, which are not fully explained. So there's a lot of work to be done on that. But the rings actually are dominated by Saturn itself. As I mentioned earlier, it's our second largest planet. It orbits the sun about 9 to 10 times the distance of the Earth to the sun, which is an astronomical unit, and takes just over 29 years to go around the sun. It's a large object, but because of its rapid rotation, and you'll see it's a gas giant, it's highly flattened. You can see there's a large difference between its equatorial diameter and its polar diameter. Its rotation period is thought to be around about 10.5 hours, made on measurements of the radio signals, which are thought to be its magnetic field sweeping around, and therefore indicative of the rotation of the interior of the planet. But this is not completely pinned down yet. But of course, one of the most famous features of Saturn is its incredible low density. It's a lot less than water. It's about 0.7 of water. And this is because of its internal structure. Like Jupiter, it's thought to be a gas giant made up predominantly of hydrogen, very much akin to our sun. Some theories suggest that there's a rocky core, a silicate core at its center, maybe several times the mass of the Earth. And because of the immense pressures that exist on the hydrogen, towards the center, this hydrogen gets squeezed either into a solid or a liquid and acts as a sort of metal, which is probably where the magnetic field originates from. But as it's mostly hydrogen, molecular hydrogen, it's really a gigantic gas bag, nothing else. Spacecraft have also looked at its upper atmosphere, which is very cold. It's about 100 degrees Kelvin or minus 180, 200 degrees centigrade, very cold indeed, but it warms up as we go deeper into the atmosphere. And its spacecraft have found that the atmosphere's got haze above it. And it's believed, like Jupiter, there are various layers of ices, ranging from ammonia ice, ammonium hydrosulfide, and maybe a few hundred kilometers below what nominal zero for reference in the atmosphere is made up of water ice. And water would be an important factor in something I'll describe a bit later on. Another characteristic of Saturn, like all the other giant planets in our solar system, they have very fast winds. What we see here is the dotted line is actually the best estimate of the rotation of the interior planet. And relative to that, we've got the wind profiles plotted versus latitude. And you see both with Jupiter and Saturn, they have very fast rotation rates at the equator and alternating wind speeds as we move further north and south. And these peaks and troughs of the winds are analogous to our jet streams. Uranus and Neptune are a little bit different. And of course, as they're much further away, we haven't quite got the resolution on their wind speeds. The equatorial regions seem to be moving a lot slower than the north temperate regions, and nobody knows quite sure why this is. But Saturn certainly has a very fast eastward moving wind speed at its equator. It's the fastest one known, and then it drops off very rapidly to have a smaller jet streams as we move further north. If we've already heard about tonight about the parade of the planets, Jupiter is well placed for observation now, very easy to spot, and even with a small telescope you can see the multicolored bands. For historical reasons, the dark bands are called belts and the lighter regions are called zones. And even with a relatively small telescope and good night seeing, you can see these bands are not regular. There are features inside them, of which the most famous is the Great Red Spot. And these represent, if you like, storms or weather features in the upper atmosphere. The red spot, as an aside, has been slowly shrinking over the last couple of 100 years or so. Whether it will continue shrinking, nobody really knows. And recently, there's been two major outbreak storms in the two major belts, in the South Equatorial Belt and in the North Equatorial Belt, North Tropical Zone. There's a lot of detail there. But if we look at Saturn, which has now disappeared, it looks a little bit blander. It too has bands and belts like we see on Jupiter. And we only really see both hemispheres when the rings are close to edge on. When the rings are wide open, not only is one hemisphere tilted away from us, but that hemisphere is hidden. But even with larger telescopes, it tends to be that all we see is a few bands and no activity at all. But we do actually have activity in Saturn's upper atmosphere. And probably one of the reasons, the most obvious one, is that Saturn is a bit smaller than Jupiter and it's twice as far away. And so if we had a 6-inch telescope to get the same spatial resolution, we'd probably need a 12-inch or 30-centimeter telescope to get the same resolution. But I'm sure, as many of you realize, that digital imaging of the planets has really enabled amateurs to produce images with backyard telescopes which have been unheard of years ago, even better than professional photography. And with this and the fact that we can enhance the contrast of features on Saturn, we can now actually image some storm features from time to time. Not the same activity as Jupiter, but still they do exist. And in fact, features have been observed on Saturn over many years. On the left, we've got a drawing by William Herschel that shows this incredibly dark spot. And to the best of my knowledge, there's nothing else like that in the Saturn Observational Archive. So whether this was real or illusory, I don't know, but Herschel was a good observer. On the right-hand side, we have an image taken by amateur Stefan Buda, and shows perhaps a more typical feature that can be resolved sometime. This was fairly quiescent. Just below the rings and the shadow of the rings there, you can probably see there's a light spot, and spots in the equatorial zone and darker spots in other latitudes do occur from time to time. But when the Cassini spacecraft went into orbit, it carried imaging systems to look at the planet's atmosphere and the satellites, and also carried a tongue-twisting unit called the radio plasma wave subsystem. And on there you can see on the left-hand side of the diagram these antennae. These were designed to study the magnetic and electromagnetic environment of Saturn, and it came up with a surprising result. Shortly after Cassini went into orbit around Saturn, it discovered a bright storm. It got nicknamed the Dragon Storm for some reason, and it was in the southern hemisphere. We can see the storm, this bright spot towards the upper part of this diagram. But the plasma wave experiment found that it was getting radio emissions from Saturn that's closely correlated with this storm. And they actually found out that the radio emissions were what you'd expect from bolts of lightning. So this particular storm was nothing more than a gigantic thunderstorm, a violent convective event producing bolts of lightning, which were picked up by the Cassini spacecraft. But interestingly enough, this type of storm has been observed by amateurs for quite on and off. They tend to last a few months and then disappear, and then a couple of more come up. And as you can see in the center of this disk here of Saturn, this image taken by Ian Sharp, there's a sort of bright spot, which is the same object seen by Cassini. And these are cropped up from time to time, are at the same latitude. So our American cousins called this Storm Alley. And again, every time one of these storms occurred, like the emissions from lightning bolts were picked up. So these were violent storms compared to some of the others. This type of feature sometimes can be picked up with an 8-inch or 20-centimeter telescope from time to time. But big storms on Saturn are sadly rather rare, and they only occur every so often. And the last occurrence was in 2010 and 2011. It was first picked up by the plasma wave experiment. It picked up bursts of energy indicating violent convection lightning. And I'm not sure how it will show up on the screen. I've added an arrow there, but just at the end of the arrow, there's a tiny little bright spot in the northern hemisphere. And over the next few days, this started to enlarge very rapidly. And we can see an image taken of Saturn of this storm. It's got a bit bigger by an Iranian astronomer. I'm not sure how to pronounce his surname. I do apologize. And literally over a couple of days, it got bigger and brighter and started to expand outwards in longitude as well. So, and this is a view taken by Cassini. And in the center of the head of that storm is a dark region, which actually turned out to be a large vortex, which I'll come to very shortly. And over time, the head of the storm and this vortex began to separate. One was moving faster westwards than the other. And this is a picture taken by an American amateur, Jim Phillips, using a 20-centimeter telescope, which I think compares fairly well with the Cassini image. It shows the same basic features. And this storm began to expand and go at the same latitude all the way around the planet. So eventually, this is a picture taken by ACE planetary imager Damien Peach, shows the extent of this storm. On the top right, there's this bright spot, the top left rather, there's this bright spot, which is the head of the storm, and all this turbulence that looks like a comet's tail trailing behind the head. But actually, that's not strictly true, because the head was moving slower than the winds around it. So the winds were moving faster to the right or easterly. And what seemed to be happening, the storm was interacting with these winds, causing all this turbulence, vortices and eddies in its wake, causing this disturbance as it went around the planet. I mentioned earlier, this is a close-up of the head of the storm, taken obviously by Cassini. And wouldn't it be great if we could get telescopes where, as amateurs, we could resolve to this sort of level? And it shows the head of the storm and the turbulence in its wake, but it also shows the appearance of the blue dot of lightning. And this was the first time lightning had actually been imaged on the planet. So these were huge lightning bolts going on virtually all the time. The vortex separated from the head, and in the upper, on this image taken by the Hubble Space Telescope, it's this dark region up in the northern hemisphere, and it was also imaged by amateurs. It started to merge with some of the darker belts, and I don't know if you can see my pointer, but it's that large dark feature in the Dave Tyler image there. And again, a Cassini image showing a close-up of this vortex. And it was huge. It was certainly bigger than the Earth. It was spinning in an anticyclonic manner, which means anti-clockwise in the northern hemisphere. And it was certainly, most likely, it's one of the largest vortices seen in any of the planet's atmosphere. And to prove that it was spinning, this is a time-lapse image of it. So I said anti-clockwise, spinning clockwise here, of this vortex shown in close-up in time-lapse. I said this was a huge feature indeed. Now, the two storms, the head and the vortex, were separating from each other. And it was predicted because of their relative motions, they would eventually come back together again in the mid or late June of 2011. And nobody was exactly sure what was going to happen. But the position of the head of the storm is shown by the white arrow, the bright spot on this Saturn image. And the dark region just to its left is the vortex. And it gradually come together. And unfortunately, it was a time when Saturn was approaching solar conjunction at the time. It was low in the sky for many observers and the seeing wasn't very good. But it did seem that they eventually came into contact, and the head of the storm was actually destroyed. In this image, taken by Aussie amateur Trev Barry, we can just, the red line marks where the position of the vortex is, and there's a few brighter spots just to its south, and these may be the remnants of the head, but almost certainly the head got destroyed when they came into contact. And it's again confirmed by a Cassini image, which was taken on, these two images were taken on June the 14th and July the 12th. And in the upper image, you can see the red diamond shows the position of the vortex, the white diamond shows the position of the head, and they came together in late June, and by July the 12th, only the vortex remained and the head was destroyed. Interestingly enough, the plasma wave experiment recorded lightning bolts almost continuously since the storm was first discovered on December the 5th. And even though the head was destroyed at the end of June, the plasma wave experiment still kept picking up these radio bursts indicating lightning for about a month afterwards. So, and you know, nobody knows why that is. Maybe there was convective cells happening in the wake of the head of the storm. But it's interesting to note the lightning continued for a more extended time. Such storms, as I said, are rare. And to date, only 6 have been of these type of storms have been observed. They were originally, if you look in the literature, they're called great white spots because initially that's how they appear in telescopes. And the first one was discovered in 1876, and the last one we've seen is in 2010, 2011. And perhaps the most famous of these types of storms was the one in 1933, which was discovered by W.T. Hay, or better known as Will Hay, who was a comedian in the music halls and films at the time, with films like Ask a Policeman or The Goose Steps Out. He was a keen amateur astronomer, and he had a 6-inch refractor where he discovered this spot. If you look closely, set the first 5 occur roughly 1 Saturn year apart, very roughly. It varies a little bit. And you also notice they seem to occur either in the equatorial regions or the northern hemisphere and alternate. So in 1876, the storm originated in the equatorial zone, and then in the north temperate regions in 1903, and back into the equatorial zones in 1933, and so on. The last storm, so these all occur in the equatorial regions or the northern hemisphere, and almost invariably occur during the northern hemisphere autumn. The last storm in 2010 or 11 was early by about 10 years and occurred in the northern hemisphere spring. No similar sized storms have been noted in the planet's southern hemisphere. The nearest ones are that dragon storm I mentioned earlier. And there are various theories of why these storms erupt over a year, but there's still lots of work to be done of why they're not regular and why the last one was a lot early. But it certainly churned up part of the planet's atmosphere. It eventually died down and left Saturn looking fairly quiescent. There are a few white areas that were seen in a sort of bluish area in the northern hemisphere for about a year. But the vortex was still detected. And the dark spot you see in the center, the top end of this drawing by Ray Johnson, is actually that dark vortex. It's still ongoing. And it's picked up again in 2013 by Cassini, and it's still going even now, although it's very, very difficult to spot. This is a Hubble Space Telescope image. Mark the arrow. I'm not sure how it shows up on the screen, but there, if you look closely, there's a very tiny dark spot, which is the remnants of this vortex. I sort of liken this to the Black Knight out of Monty Python and the Holy Grail. No matter what's done to it, it still seems to keep on going. And every year people speculate it's going to disappear, but it still keeps on going. And this is an image taken quite recently by Aussie amateur Trev Barry. I have done Trevor a small disservice. In fact, I've enhanced this to 1 inch of its life. But just at the top of the arrow is a very small dark spot, which is this vortex. It still keeps on going. And this image also shows 2 of the fainter satellites, Rhea and Enceladus. So this storm has had a lasting impact on Saturn's atmosphere with the presence of this vortex. Saturn, as mentioned earlier, it's approaching solar conjunction, but it'll be opposition again in September on the 21st. It'll be south of the Great Square of Pegasus, dead easy to find, just near the celestial equator, and well worth having a look, even if you've got a small telescope. But the interesting thing, as we've slightly alluded to earlier on, is the rings are edge on. And this diagram shows the inclination of the rings. Positive values of the north face of the rings presented towards us, negative values, the south face of the rings are presented towards us. The blue line is the inclination with respect to the sun, whereas the red line, the oscillating line, is with respect to the earth. And as I mentioned earlier, what we see is the decrease as it's seen from the sun, the inclination is seen from the sun, plus its effect as the earth moves above or below Saturn's ring plane. And so we can see the rings are going to be edge on to the earth in March the 12th, which is on the 23rd rather, which is, alas, it's only a few days after solar conjunction, and edge on to the sun in May. Now, unfortunately for us in the northern hemisphere, Saturn's going to be very low at the time, but maybe some people might see the rings come back into illumination from the southern hemisphere. But even if you want to see really narrow rings, not quite edge on, if you wait until sort of post-opposition in October, November timeframe, there'll only be half a degree inclined to us, so they'll appear incredibly narrow indeed. So seeing things like the Cassini division will be, well, it'd be nigh on impossible, it'll be so narrow. But the advantage of having the rings edge on is that they means that the satellites will be undergoing phenomena like Jupiter and Saturn Jupiter's satellites as well. This is a diagram showing observations showing the rings when they come into sunlight. This was made in 1995 by British amateur Dave Graham, and you can see in just a day the slight inclination, change in the inclination of the rings where they came into sunlight, enabled the rings to be seen. And certainly, if we could see the edge-on phase more readily from the northern hemisphere, I would imagine with a day or two of them being edge-on, they would actually be visible to medium-sized telescopes. But one other advantage of the rings being edge-on is that the satellites, most of the orbits close to the ring plane, so we see them edge-on as well, which means that we can get phenomena of the satellites taking place like we see with the four largest satellites of Jupiter, notably eclipses, transits across the disk, and occultations. Now, seeing the smaller satellites go across the disk of Saturn is very, very difficult and requires larger amateur instruments. But Titan is one of the objects that can be seen very... Oh, sorry, I've jumped ahead a little bit. Forgot to mention, with the rings edge on last time in 2009, we couldn't see it from the Earth, it was too close to the sun, but it was observed from the Cassini spacecraft. And this shows ring B and the Cassini division above us. And what it actually shows, as you can see here, is shadows cast by ring particles that have been elevated above the plane of the rings by probably one of the satellites by about 1 kilometre, showing that the rings are not uniform thickness. So this is a remarkable observation from the Cassini spacecraft. But as I mentioned earlier, we see the satellites almost edge on. And the rings actually do reflect a lot of light. And when the rings are edge on, it reduces the glare around Saturn, and it means that some of the fainter satellites that are close into the planet can be more readily seen. And as I mentioned earlier, they sometimes go into transits and occultations and eclipses, which are difficult to see with small telescopes, apart from the largest, which is Titan. And this year, we've had a number of occurrences when Titan or its shadow have gone across the disk. They're not spectacular events, but they're well worth observing. The upper picture taken by Gregory Shanos shows Titan going across the southern hemisphere of the planet, and the lower picture shows Titan's shadow going across. This was taken in January. The scene wasn't particularly great, but Titan, when it's in transit, looks almost as dark as its shadow. And over this year, there'll be various events involving Titan, occultations and eclipses and transits. But most of them, some of them won't be visible from the UK because the planet won't be above the horizon. Some will be, in daylight, which makes it difficult. But certainly towards the end of this year, from October to December, there are a number of Titan events taking place, or its shadow, which would be visible from the UK. And one noticeable one would be, easy to remember, would be a shadow Titan crossing the disk on Christmas Eve, on December the 24th. By the time it's finished, at just after 10 o'clock, Saturn will probably set. But the simulation I've given below is one of Titan just about 6 o'clock in the evening. And it's certainly big enough to be seen with small telescopes. I know people have seen previous Titan transits using sort of 70, 80, 90 mil aperture telescopes if the seeing is good. So it's certainly a thing it's certainly Christmas Eve we want to remember, and it would be, if it's clear, get your telescopes out and have a nice look at this event. As I mentioned earlier, Saturn has got a large number of satellites, and to spend a lot of time describing more would take far too long. But the largest of Saturn's satellites is Titan, discovered by Christiaan Huygens, and it's the second largest satellite in our solar system, just after Jupiter's Ganymede. It's actually larger than the planet Mercury, and has quite a dense atmosphere of nitrogen and methane and other hydrocarbons. And we really need to see the features underneath this smog, if you will, and to use the radar on the Cassini spacecraft. Of course, the main thing was that the Cassini spacecraft carried a lander named after Christiaan Huygens, which actually managed to get down to the surface of the satellite, and it showed this sort of smog-filled atmosphere, and as it descended down, it sort of what looked like riverbeds and everything else, which are probably hydrocarbon lakes. So it's a fascinating world. And some people think it might be a place that life might get started if it wasn't in such a deep freeze. Another interesting satellite is satellite Iapetus. This was discovered by Cassini of Cassini's division fame. And when he found it, over a number of months, excuse me, he found that it varied in brightness. So when it was to the west of Saturn, as seen on the sky, it appeared moderately bright, but a lot fainter when it was east of Saturn. And Cassini argued that there must be a dark region on the satellite, and the spacecraft have proved him to be correct. In fact, this dark region is now called Cassini Regio, after Cassini. It's got a number of large craters. It's an icy body, but the other thing unusual about Iapetus is that it is in fact almost walnut shaped. For about, I don't know, 270, 280 degrees around its equator, it's got this huge ridge of high mountains, some getting up to about 10, 11 kilometers high. And again, this is something unusual. Nobody knows why it's got this particular shape. Undoubtedly, the darling of the Saturnian system satellites is satellite Enceladus. This was discovered by Sir William Herschel. He discovered another satellite, Mimas, and said he was an avid Saturn observer. And spacecraft has shown this is a very icy world. A lot of the terrain is relatively flat, but the key thing about it is these plumes that come off from its south pole, some sort of action where material from inside Enceladus is being spewed out into space. It's believed that this satellite has got an ocean below its crusty surface, not dissimilar to Jupiter's satellite Europa, very similar worlds, very icy worlds, highly reflective worlds. And it's this material that's coming off from Enceladus is going into orbit and is believed to be forming the tenuous E-ring. So Enceladus is certainly an important object. In fact, all of the satellites, major satellites of Saturn, seem to be icy worlds. And two of them, Tethys and Dione, are unusual because they have Trojan satellites. The only satellites known to be Trojan objects, one in the leading Lagrange point, one in the following Lagrange point, which is rather unusual. So the satellites of Saturn are a remarkable system, and it's only through spacecraft that we've actually begun to realize that these are actually worlds in their own right. Though many of the satellites are very small, and there are a number of satellites that have been embedded inside Saturn's rings. In fact, a few years ago, the Cassini spacecraft imaged a bright object in ring A, which dissipated again. Many people think a lot of particles had come to form a small satellite that dissipated again. What about the future? Well, 4 spacecraft have been to Saturn so far, Pioneer 11, Voyagers 1 and 2, which were all flyby missions, and then the Cassini, the remarkable Cassini spacecraft, was able to observe Saturn for about half of a Saturnian year. It was crashed into the upper atmosphere in 2017, primarily so that it wouldn't crash into Enceladus and maybe take some contamination with Earth microbes onto a world which we think life may exist. Getting spacecraft up and to other worlds now is an expensive venture, and there are always concepts on the drawing board. People would like to go to Titan, certainly get another lander on Titan, study Saturn's system again, maybe look at some of the other satellites, but they are rather expensive. And whether we'll actually see a spacecraft launched to Saturn in the near future, I honestly don't know. It's probably down to money. But at least we've also got the Hubble Space Telescope that observes Saturn from time to time. There's a program of observing the outer planets several times a year. And of course, we've got the remarkable James Webb Space Telescope as well, which operates in the infrared. And this is an image of Saturn taken in the infrared, and it shows the bright rings and some of the satellites and divisions as well. And some large Earth-based telescopes observe Saturn from time to time. But whether we'll get a spacecraft off into the future, I don't know. But Saturn, I know a little bit biased in it, is a nice object to look at. It's, if you've got all the fancy equipment like imaging equipment, a larger telescope, it's a little bit more tricky to image than, say, Jupiter or Mars because it's a bit fainter. But it's well worth having a go. If not, it might pick up some of the storms that occur from time to time. But if you haven't got all the fancy equipment, it doesn't matter at all. Even a small telescope will, except when they're really edge on, will show the rings. It will show a few satellites. A good 5 or 6 inch aperture telescope is more than capable of showing the rings, Cassini's division when the rings are open, several of the belts, and several of the satellites as well. And it makes a nice, pleasant observing package. And of course, if you have a small telescope, look out for the Titan transits in October to December, and when the rings are really narrow as well. So I think my time is almost up. I aim for about an hour. It's just a little bit low. So thank you very much indeed for listening.
Thank you, Mike.
Voices
Excellent. It's good to be reminded of our sort of ringed partner now that it's disappeared and we won't get it back until later on in the year. But what questions do people have? Ah, yes, yeah.
I'm just going to do a runner.
Right. Yeah, thanks for incredibly informative talk. So thank you. One of your slides, you showed the temperature gradient as you moved away from the surface of, or the center of Saturn, and the temperature started to decrease and then actually increased in the stratosphere. So I wondered if you could say why that is.
I honestly don't know. It's certainly, I think the general trend is for the temperature to increase. So we can see it's getting hotter here. I'm not sure why it's the turning point is in the troposphere. It is cold up there, and it does go as you get deeper, it does get warmer. I know the Earth has a thermosphere where the temperature drops off and gets warm again, but I'm not sure exactly why this curve is as it is, but it's certainly getting warmer as we get deeper, and almost certainly gets up to several thousand degrees centigrade when we get in towards the center of the planet. Well, that's what it's believed to be, partly because of all the pressure pushing onto the gas that's towards the center. But I'm sorry I can't fully answer that one.
Okay, I'm going to steal a question if I may, Mike. What's the latest thinking on the age of the rings and how long might they stick around for?
Ah, yes, that's a really interesting question. There are 2 schools of thought. One is that the rings were formed either when the planet formed or shortly afterwards, and so they've been around for a long time. There's another school of thought, particularly from some measurements from the Cassini spacecraft, which found material going off the D ring towards the upper atmosphere that suggests that the rings are not as old as that, maybe a few tens of millions of years, 100 million years, rather than the billions of years, and they won't last forever. And one of the reasoning behind that is that the rings are bright. If you compare them to, say, the rings of Jupiter, slightly different to Jupiter, Saturn, and Uranus, but they're very bright. And a lot of people have argued that over time, interaction with solar energy, radiation, and meteors would make them less bright, and therefore they haven't been around for a long time. The other idea that they've been around for a long time is that people think, well, if there's material eroding on things and rocky material from comets or meteors hit them, the particles are in motion around Saturn. They might grind together and rub off this, if you like, dark weathering and still remain bright. Which is the true theory, the pros and cons to both? I honestly don't know. But let's say there are two schools of thought on this. Which one will turn out to be the correct one? Maybe the only way we'll know for certain is to borrow Doctor Who's TARDIS and go back in time to find out.
Anyone got a TARDIS? No?
Yeah.
I think we have one from Paul, which popped up. What was that? Oh yeah, why is Titan less common in terms of transits compared to, say, Jupiter and its Galilean moons?
Well, the thing is that Jupiter's moons, we orbit around the planet's equator. Jupiter's equator, its pole is tilted at a small angle to its orbit. The orbit is a small angle to the Earth's orbit. So effectively, we are seeing the orbits of Jupiter's satellites almost edge on. Not always. In fact, at an extreme, although the inner three satellites can go into transits for a couple of years either side of the equinox of Jupiter, Callisto misses the planet entirely. So, but effectively, we're seeing the rings edge on virtually all the time. For Saturn, however, it's a little different because for the satellites from Titan inwards orbit in the plane of the rings, and of course, as we've seen, that the rings are not always edge on to us at an angle, and it only requires a small angle for Titan not to cross in front of the planets we see them. So Titan's transits occur for about a year either side of the ring's edge-on phase. And they're not frequent because Titan takes nearly 16 days to go around Saturn. So it's, there's an occultational eclipse, 8 days followed by a transit. Allied to that, with the change in inclination of the rings, because the Earth moves above and below the ring plane, sometimes we only get shadow transits, sometimes we get both, or sometimes we only get transits of Titan itself. So it's really dictated that really we only get a window of about 2 years every ring plane crossing. So that's why they don't occur very often. And with a 16-day orbit, it means they don't occur until every 16 days. On top of that, to be awkward, Titan's orbital period is almost 16 days. So sometimes it's visible from one side of the Earth and not the other. In the last ring plane crossing, virtually all the Titan transit events weren't visible from the UK. They were all visible from the other side of the Earth. So that's why a combination of factors why they don't occur very often.
Thanks for that. Paul, hopefully that answers your corrected question.
Please come back.
Yeah, which was, yeah, you got it, which is, it's a geometry thing which changes over time.
Yeah, effectively.
Okay, what other questions have we got? We must have other questions. Yes.
Thanks, Mike, for a very interesting talk. I think mine was a crazy suggestion rather than a question, but
who am I talking to, please? Who am I talking to?
This is Prim.
Okay, hiya.
Prim, hi. So you showed a picture of Herschel's image with what could have been a storm on it, but my first reaction when I saw it was, could it have been something impacting the planet? I mean, later on you showed me some other pictures which showed that there were some very big storms on Saturn, but that was just my first reaction. Is that crazy?
It's not crazy at all. Unfortunately, Herschel was probably one of the few people doing that, and it does seem to be rather big. And whether I can't imagine Herschel being in error. He was a very good observer. So could it be an impact? Possibly could be. I mean, as we saw in 1994 with the Schumacher-Levy 9 impacts, some of them were quite big, or they left scars that were quite big. So it's possible, but unfortunately, it'd be nice to think it was, but unfortunately, I don't think we've got one way of proving it. It's an interesting idea, and it's not crazy.
Okay, thank you.
And that was driven in Bath, remember? 1780, he was still in Bath.
Yes.
Yeah. Don't know which house he was in, but yeah.
He moved a little bit, didn't he?
He did, yes. 6 or 7 different houses for his time in Bath. And then his brother stayed on a lot longer than that. Anyway, that's an aside. Is it right that we've got some interesting patterns? Is it on the northern pole or the southern pole? In terms of, just like Jupiter, we're getting some complicated geometric patterns.
Good question. Now, just in case, I'm sorry I'm having to scroll quickly through things, but certainly I prepared a few extra slides just in case I get some questions. And this one shows the northern hemisphere of Saturn, and it's this so-called North Polar hexagon. And although they're on Jupiter, Juno has revealed these sort of storms that are sort of in patterns of pentagons and 6 or 7 of them. Saturn has got this hexagon structure, which was discovered by Voyager, but better imaged by Cassini. And nobody knows exactly what it is. There's various theories, but it might be a standing wave in the atmosphere of combination of the various winds around it. So that's the one in the southern hemisphere. It's just got a small polar vortex. But this is the nearest thing that we've got to what seems to be around on Jupiter, this North Polar hexagon. And it's big. It's, it's bigger than the Earth, so shall we say. The arms are about 12,000 kilometers across. So that's the nearest thing we got. Is there anything else that you alluded to? But as a matter of interest, it's been seen by amateurs, and this shows the hexagon. You can just about see the vertices there as well. So it's an interesting structure. That's the nearest thing that we've got.
Excellent. Any other hands? Any questions from our online audience? We have one from Paul. No. So just to close things out, in terms of what are you looking forward to in the research? Because we had Professor Lee Fletcher talking about all the aurora that he was currently recording and what that was telling us about not just Saturn, but also the ice giants out there. But what are you looking out for? Are you most excited about things like Dragonfly?
I think any spacecraft that goes there, even if it does 50% of what Cassini did, I think would be exciting. Cassini was remarkable in many ways. I mean, they got the funding to keep it going for half a Saturnian year. And I would imagine it's going to keep the scientists going for years to come. So that would be exciting. I think from an amateur perspective, we've suffered over the last umpteen years because Saturn, from us in the northern hemisphere, has been below the celestial equator, which usually means that the scene isn't quite as good as it could be. And most of the high-res images, amateur images, have been from people in Australia. However, Saturn's slowly moving northwards. The conditions are getting better, and I'm looking forward to seeing many amateur images of the planet. Now the South Pole is tilted towards us. And I think one thing that I would be looking out for, them dragon storms that occurred in the southern hemisphere, it'd be interesting to see if we get a spate of them occurring as the South Pole gets tilted towards us. Whether or not we'll get another big storm in the foreseeable future, I don't know. The other one was early, so whether it would be 30 years or 40 years, I don't know. But from time to time, we do get storms that occur. So it's a case of monitoring and hoping for something to happen. But certainly another spacecraft going to Saturn would be really good, a dedicated spacecraft. And I think particularly if it went into orbit around Titan, with a ground atmospheric penetrating radar would be interesting as well. Get a more detailed map of Titan and its system.
I think we've got one final question from Ben. Yes. He's missing those beautiful rings. So when will they be wide open again? How long does he have to wait?
Let me just go back and just go to the diagram I showed a little bit here. Sorry, it takes a little while to scroll through everything. Let's just, sorry about this. We'll come to the diagram, we'll get in there.
There you go.
Right, so as we can see, the equinox is in March. They will start to open up again. Be very narrow this year, but they'll start to open up again. And within a year or two, there'll be, you know, 10 or 12 degrees open up to us. The maximum will be in 2032 when the south face of the rings will be at their maximum tilt. So that's when you know, they'll be at the maximum. Astronomy, unfortunately, has to be a long game sometimes. But even when they're narrow, they're interesting to look at. Like I say, within a year or two time, they'll be opening up, and the Cassini division will start to become a little bit easier to see with smaller telescopes. And let's say it'll be another few years before they get maximum inclination.
Okay, Ben, so you've only got 7 years to wait. All right.
No, not quite as long. I imagine a year or two, be able to see.
All right, well, hands together again. We'll thank Mike for a wonderful talk.
Yeah, pleasure.